Test. Nice. Okay. So we are in the water and wastewater sector, industrial sector, renewable energy, tunneling, mining, and federal for military airfield paving, dams, fish slaughters, and then finally we are in the materials business as well, where we do crushed aggregates, concrete aggregates, and specialty sands and rocks. So a little setting the stage before we dive into the content. So prior to 2023, I guess prior to 2023, most of our landscape was a mix of on-prem applications and SaaS applications. So we hosted a lot of our applications on-prem. And specifically looking at our J.D. Edwards footprint, it was all on-prem Windows virtual machines on a 2-node Oracle rack cluster. And within J.D. Edwards itself, if you know anything about ERP, we utilize most of the main modules, so distribution, finance, management, manufacturing, inventory. We have approximately 3,000 users across several hundred sites. And prior to the project that we're going to talk to, we were on 9254 platform. So why am I here, and why did we eventually decide that we needed to complete some type of migration? Well, in September of 2022, our data center gave us a notice to vacate. So we had a year from that notice to migrate every single one of our applications out of the data center, including our ERP system. And our enterprise architecture, from a strategic standpoint, said, well, let's go to the cloud. Everybody else is doing it. So while the presentation today will mostly dive into our Oracle ERP system on AWS, I do want to call attention to all of the other applications that were migrating to AWS at the same time as our ERP system. And it's funny, the things that you find as you go through an exercise like this. We found applications that were running that we didn't even know about. So it was a good exercise. So the approach that we took was to stand up this new infrastructure in this new cloud platform, whatever that might be. And instead of migrating our existing environment, we said, let's just stand up a new instance of J.D. Edwards in the cloud. And in doing that, we're able to run both instances in parallel. So we don't really impact the business other than for testing and the weekend of go live. So with that in mind, I was like, I feel like this is an opportunity for a little bit of scope creep. Disclaimer, by the way, my presentation was very funny until I met with Amazon Legal and they moved all my GIFs. So if you don't laugh today, please thank Amazon Legal because it's not going to be as funny. Anyway, so scope creep. At the same time, why not upgrade to release 23, which is the latest on J.D. Edwards, and why not upgrade to 64-bit? So with our platform prior to 2023, we were stuck. We couldn't do any other upgrades because we were in 32-bit land. So with this big of an undertaking, and because it was essentially every single application that Granite owned, we decided that we needed help. So we kicked off a vendor selection process. And we started with an RFP, or a request for proposal. And in that RFP, we laid out everything, well, what we thought was everything that we wanted as part of this migration and upgrade. So we wanted to know about the company's strength. What's the size of the company? What does their profile look like? What's their experience? Have they done a migration like this in the past? What's their partnership look like with the different cloud providers? What's their cost? How is it structured? Is it fixed? Is it time and materials? Is it a hybrid model? What's their proposed schedule? How long do they think it's going to take to migrate our Oracle ERP? And how are they planning to do this? What's their solution for doing that? And Granite we did some research, and we found several vendors that were pretty well known for doing a project like this. So we had submitted this RFP to 5 different vendors, and we really waited for their responses. And then when those responses came back, we put together an RFP selection committee who rated all these responses. And there were certain categories, and we'll go through those in a second as far as like what we rated each of the RFP responses on. But they were rated 1 to 5, and then some of the categories had more weight than the others. Like the company may have had a lower weight than what their solution looked like. So speaking of company, looking at their company as far as a rating 1 to 5, how comfortable are we with this vendor? What's their size? What's their reputation? Could we talk to other people that have used them in the past? How about their JDE cloud partnerships? What's their cloud migration experience look like? How does their solution look? Is it feasible? Does it look like it's something that we at Granite are going to be able to accomplish knowing how Granite is? And DR was a really big thing for Granite regarding our Oracle ERP. So DR solutioning was one of the ones that had the most weight for us. And out of this, we also let the vendors know that there was a possible managed services option that we could also get some information on. We looked at cost, we looked at schedule, people, process, and you can tell, that this was a super timely, sensitive process. We spent a lot of time going through and rating all of these vendors. And then we decided in the end that none of that mattered, and we picked the cheapest one. I'm just kidding. We picked the one with the highest score. So in the end, we ended up selecting a vendor called ERP Suites. And I give a lot of the success of the project to Granite, but also to the vendor. They brought a lot of knowledge and expertise that we didn't have in-house. So this partnership really helped to make this project successful. So with ERP Suites now on board, we said, okay, we have this ERP system. What cloud should we put it on? Can you help us determine what's the best option for Granite given this set of requirements? So from a Granite standpoint, we were really only interested in looking at Oracle Cloud Infrastructure and Amazon Web Services. So going through and looking at different areas of comparison, we focused on licensing around Oracle database licensing. What does scaling up look like? What does scaling out look like? If we needed to do either of these, will we have to purchase additional licenses? And there were some pros and cons to that. And then as well for WebLogic licensing, we did the same. And then for cost was a big one as well, especially around egress and ingress charges. So Granite has all of these other applications that I'd listed out here, plus others, and not all of those were going into, say, the same cloud provider. So we needed to understand what ingress and egress charges looked like from one cloud provider to the other. And like I said, disaster recovery was a big one, And we wanted to know what cloud options there were for replicating between the different tenancies and what technologies were there. So disaster recovery, I've said that this is probably the biggest one. Here I'm going to highlight it again. DR was the biggest one for Granite. We didn't have any in-house knowledge on OCI. Other apps were already migrating to AWS. So the cloud that we selected, anybody want to guess? Anybody guess? Anybody? 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 AWS. Otherwise I wouldn't be here, right? Come on. So yes, we decided to select AWS, and we felt like AWS offered the overall lowest complexity, but also offered Granite the best DR solution that we could get. So we move into implementation, fast forward a little bit, and we start really diving into the project timeline. So we spent 12 weeks planning, identifying third-party vendors, trying to get third-party vendors on board, and designing and building out this environment in AWS. And then we spent another 12 weeks implementing, getting code current, completing retrofits, and for those of you that aren't familiar, whenever you do an upgrade on Oracle JD Edwards, if you have any customizations and you do an upgrade, all of those customizations get wiped out. So we have to go back as part of the project and add all of your custom code back into the platform. So we spent a lot of time doing retrofits, testing, mock cutovers, and then you can see a little detailed kind of breakdown of the timeline. We went through a couple mock cutovers in there. We spent a significant time doing system and integration testing, where that was mostly IT testing, because why would we put users into a broken system? So let's make sure that it actually works before we open the doors for them to get in there and start testing. And then we started building out the infrastructure. And here, AWS Terraform was super helpful. With Terraform, we were able to create the VPC, the subnets, the network security groups, provision servers, provision databases, apply firewall segmentation to the servers, and we were able to configure backups, and we did all of this in 2 hours. It's a pretty big win. As we were going through the mock cutovers throughout the process, we started putting together what a go-live would look like. We started building out a punch list and including all of the gotchas, not only for specifically to ERP, but also to any of the bolt-on applications to that ERP and how those integrations would be impacted by the migration of E1. So our go-live punch list was 216 items. We were working around the clock to get all of these items completed. And as you marked an item complete on the punch list, it was creating a nice little graphic in the background where at any point in time you would be able to get into the system and see a status update of kind of where we were in which part of the project and what was happening and who was doing that. So prior to the migration, we knew that we had a lot of moving pieces here. And we had to figure out a way to get everybody organized and everybody to stay on the same page. So we started a Teams meeting. And that Teams meeting stayed open the entire weekend for Go Live. If we ran into issues, people were able to hop onto that bridge. We were able to work through those. And we used it for coordinating, tagging people, tapping people on the shoulder, saying, hey, you're up next. And the Friday before, the Monday of Go Live, we brought the system down for everybody but a handful of users. And we told these users, like, hey, we need you to get into the system. Please don't complete any transactions that are going to update the database. Like at this point, we want you to get in there. We want you to run some data integrity reports. We want to do some data validation. We ended up running some SQLs so that we could some row counts, but we didn't even sum just the row count. So specifically in like the payroll areas, we even summed totals to ensure that we could make audit happy that everything was migrated successfully. And then post-migration, we did the opposite, right? So we brought the system back up for that handful of users. We let them run those same reports. We ran those same SQLs. And we compared the before and the after data. And in the end, it was a success. Now, because I had to get rid of my GIFs, this is my attempt at drawing a touchdown stick figure. So it was a success. Everybody was happy. We felt pretty comfortable at this point, and we were not going to turn back. We were not going to go back to our on-prem system, no matter what happened from this point forward. So we were able to migrate our entire Oracle ERP in less than 48 hours of downtime because of the approach that we took. Now, I'm a little bit nervous about presenting this performance section because I thought I was technical. I really thought I was technical as a developer until we start talking about performance, and it just goes way over my head. So these slides that I'm going to present, I really want to give credit to ERP Suites because they helped me put together this information to present for you today. And I'm going to do my best to articulate it to you. And hopefully it makes sense. If it doesn't, just tell me it does so that I can feel good. And I feel like I actually, helped you guys learn today. So when you're talking about JD Edwards, there's essentially two big bottlenecks. So bottleneck number one is your database server. Bottleneck number two is your enterprise server. The bottleneck on the database server is your disk I/O, and your bottleneck on the enterprise server is your single core clock speed. So in looking at these two, in regards to batch processing or application processing, your database server is your bottleneck 90% of the time. The other 10% when your database server isn't the bottleneck, it's your enterprise server. So how can we fix this? How do we help the database server so that it's not that bottleneck? Well, we minimize going to the disk because disk I/O is where we slow down. So let's try not to go to the disk. And by doing that, by not going to the disk, we have to add more RAM. So I think there's a saying like just throw more RAM at it. Well, in this case, I think that's true. And when you do have to go to the disk, just make sure that you have a really fast disk. And on the enterprise server, it's pretty simple. Just increase the speed of the clock. But the question is, when is increasing the clock speed actually helpful? And to help explain it, like it was explained to me, we're going to use a road, essentially. So we can think of a core as the number of lanes on a highway. To increase, or to add another core, we're simply going to add another road or add another lane. And this is the traffic that you essentially have going back and forth. And the clock speed here in this example is equivalent to the speed limit on that road. So the single core clock speed is equivalent to the speed limit. So the faster the clock speed, the faster the speed limit for the individual car. So adding another lane might be helpful when, say, when it's congested, when we've got a lot of traffic. So in the situation of looking, say, at adding 4 lanes. So now we've got 4 lanes total, and we've got gridlock. So if we were to double that and add another 4 lanes, now maybe we don't have that gridlock problem, we don't have that congestion anymore. So in this scenario, this is where it would make sense to increase your clock speed, and this is where you would see that performance. So if you have a relatively free highway, your clock speed, increasing that clock speed would be helpful at that point. So now we start talking about optimizing the storage on AWS. And we'll start with 2 different classes in AWS for storage. One is the IO2, and I believe now it's called IO2 Express. And then the other one for storage is GP3. So for IO2, let's take a scenario where we have 400 gigabytes of disk space, and we want to provision that with 12,000 IOPS. And if you were like me before the start of this project and you have no idea what IOPS are, it is the input and output per second on the database. So in this scenario where you've got the 400 gigs, 12,000 IOPS, we're looking at approximately a monthly price of about $830. Now, if we were to look at GP3 with a similar scenario, where we've got that same 400 gigabyte disk space, now for GP3, the interesting thing about it is that for each volume that you provision, you automatically get 3,000 worth of IOPS. So in this scenario, I'm not going to provision this with 12,000 IOPS. Since I already have 3, I only need to add an additional 9. And in this scenario, we drop the price from $832 approximately to $77. Now, we can take this a step further, and if you remember how I had mentioned that for every volume of GP3, you get those 3,000 IOPS provisioned. So if we were to expand that 400 gigs into 4 100 gig volumes, and now right off the bat, I already have 3,000 IOPS per volume, I don't have to provision any additional IOPS. So at this point, the bottom scenario is giving me the same amount of disk space and the same number of IOPS as the top scenario. And here, the monthly price drops to $32 a month. So taking that into consideration, we then have to start thinking about which of the two classes of the X2 processor makes the most sense for Granite. Is it the X2IE ZN, which is the faster clock speed, or is it the X2IE DN, which is giving us more IOPS? So in order to make that decision, we had to look at our existing platform and understand kind of our use characteristics. And to do that, we used a tool called Database Current State Investigation, or CSI. And we use this to capture those performance characteristics. This is a free tool provided by AWS. And there are 2 versions of this tool, and this is where this gets really important. The first version is a licensed version, so you have to be licensed for the diagnostic pack. If you run this tool and you are not licensed for that pack, it's going to generate the same pretty graphs as it would if you are licensed. And if you were to get into an audit with Oracle, you would owe them a bunch of money. So before you run the licensed diagnostics pack version, make sure that you have the appropriate license. The other version is called the stats pack. And with this tool, we were able to grab about a week's worth of data and specifically focused around the month end time, since that was going to be our highest utilization time period. So one of the graphs that came out of that tool is our average database CPU usage. And from a CPU standpoint, I know it's hard to read, but our max average here is sitting at about 4.1 cores. So from a CPU standpoint, we're not really concerned other than making sure that it fits in our current licensing landscape. And as far as our memory allocation, you can see that we're pretty consistent, and that's right at 500 gigabytes there for memory. So we were pretty consistent with that throughout that week's worth of data. And this will be important at the next step when we dive in just a little bit deeper. And then looking at our number of IOPS, so a little bit interesting, we stayed pretty close to the bottom, and then occasionally we would spike up to 50, 60,000 IOPS. And what we learned is that was due to database backups. And then we also run a tool called StarQuest, where it's replicating data out of our Oracle database into a data lake that sits up in Azure. So these spikes, they're brief, but they do get fairly intense. And then when you look at it from an average IOPS standpoint, our average max was right at 5,200, or 5,230. 5,230 is the max up there. And, it's just, so that was our average, but we have to keep in mind that we still had spikes up to that 50 or 60,000. So thinking about this in an instance type where, we know we need that 500 gigabytes of memory, we have to look at the 4x large on the X2IEZN instance. And when we do that, if you remember when I talked about earlier from the GP3 storage, we get 3,000 IOPS automatically. So here in this scenario, we're going to look at 5 1-terabyte drives, and we automatically get 3,000 IOPS per volume. And we're going to go ahead and we're going to max those out and add an additional 13,000 IOPS to total it to be 80,000 IOPS. So we're looking at 80,000 IOPS and 24 megabits per second. Now, if you look at the instance under the max IOPS, you see that we're kind of at a threshold there of 20,000 IOPS. So even though on the storage side we're generating 80,000 IOPS, the VM is going to throttle us down to 20,000 IOPS. So in this scenario, the VM throttles our IOPS by almost 75%. And again, I had another GIF in here, but instead I did some more cartooning, and this is me sad, because it throttles us so far. So take that same scenario, and now we're going to look at the X2IEDN. And same scenario with the 80,000 IOPS, the 24 megabytes per second. And here you can see that it throttles us to 65,000 IOPS. So we're still limited. It still throttles us down, but we're in much better shape here because we're only being throttled down now by 18.75%. So this one, made me happy. So I drew a little happy cartoon. So coming back to this screen, so which one is better for Granite? So in the end, Granite chose the more IOPS. And then we said, okay, so we've done all this work. We've done all this work of trying to architect a really good system. How are we going to figure out if we're doing worse or better than our current on-prem platform? So we looked at measuring performance. And we analyzed our record, we looked at batch performance and we analyzed records per second on the upgrade versus on-prem. And we sorted those results by something that's called the misery index. And if you know anything about economics, the misery index is, it refers to the inflation rate added to the unemployment rate. But in here, for performance analysis, the misery index is the average wait time multiplied by the number of executions. And we're able to use it to gauge the impact to the business. So we did all of this analysis, we sorted all of this data by the misery index, and we're surprised to find we had an 81% average batch performance increase post-upgrade. That is a significant win. And this is where, again, I had another GIF of doing a mic drop, and I had to take it out because I feel like this is a mic drop moment, so I drew myself doing a little mic drop for you. This was incredible, and our users could not be more happy. So looking at disaster recovery, I had mentioned early on that this was something that was super important to Granite. So over here on the left, that's where our E1 environment's hosted. It's hosted in the West 2 region. And on the right, we are hosted in the East 2 region for the DR piece. Between the two regions, we've set up VPC peering to set up the network connectivity. And then at the target region, we have the DR staging subnet and the DR recovery subnet. And we utilize Amazon DRS to perform the recovery from the source to the target. So this was huge for Granite to be able to get a DR solution like this. And thinking about RPO and RTO, so RPO, recovery point objective, it's the maximum amount of data measured in time that Granite can tolerate to lose. Our target before we started the project was 1 hour. And when we did our DR test, we found that we could do it in approximately 10 minutes. And then looking at the RTO, so recovery time objective, which is the maximum amount of length of time it takes us to restore normal operations after some type of event. Our target was around 4 hours, and when we did our DR test, we found that we could do it in about 3 hours and 10 minutes. So for both of those, we were under our target, which was super awesome. Now, not all projects, I guess I should say, it sounds like it went really well, right? But all projects have challenges. And one thing that we found out is, you can plan all you want to, but until you actually get into the weeds, you can't really plan for all of the risks that are going to come out. All of our third-party vendors, they were great until we needed them. No, I'm just kidding. They were great, but we quickly found out that our timeline, just because we had to get out of the data center in a year, they didn't really care. Like, they had their own priorities and their own projects and their own things that they were dealing with. So we found out that our timeline was not their timeline. It took some negotiating there. And despite all of our testing efforts and our system integration testings and our UAT testings, and Granite has 900 automation test scripts that we run as part of any upgrade that we do. And despite doing all of that, even after go live, we still found issues. We ran into some resource constraints. I don't know if anybody else has those out there, but that's a big thing, I think. It's a big problem at Granite. And the other challenge was, while we moved to AWS and did an upgrade, somebody somewhere said, hey, this is a great time to do some security hardening. Let's try this and see how it goes. So if we had to do it over, I would recommend that we remove that from the project scope. Things that went really well. So we felt like our timeline was well. We aligned with the vendor on the timeline, and we had adequate time for testing. And we ended up having to switch our go live date one time because of one of our third-party vendors that is over a pretty important part of our ERP. So it's the software that does sales and use tax. We couldn't get them on board early enough, so we did have to delay go live for a couple of weeks to get through that. But overall, our timeline worked out pretty well. Our communication, we were constantly communicating, probably to the point that it was annoying. We were sending out executive updates. We were holding meetings to talk to the business about kind of where we were in the process. The sign-off process we used for this project, it's the same sign-off process we use for anything E1 related. So the business already knew what we expected of them and knew exactly what they needed to do. Team expertise, like I said, we couldn't go wrong, didn't go wrong hiring ERP, so that's nice. Our approach, standing up the new environment in the cloud and having both of them run in parallel, we had really no business. We didn't have any pushback from the business really at all because we didn't impact their day-to-day lives. Our budget, we ended up coming several $100,000 under budget for this project, so that made lots of people happy. Our outcomes, so our director of IT infrastructure and ops, after we did our first DR test, he said, man, that was fast. The last vendor took 2 days to complete the DR. And our CIO said that this was the smoothest J.D. Edwards migration project that he and the business have ever experienced. And this slide, it's really a fun slide, and that's why I included it, but we had 1,048 sign-offs. So all of our testing that we completed, the business has to go through and they have to sign off that they agree with the test results. So we had 1,048 of those. We had 19 final approvals, so that goes up to the director level where the directors then sign off on the sign-offs. We had a total of 1,593 PDF documents that constituted our proof of testing. And we had 110 before and after migration validation reports proving that there was no data integrity issues. All of this totaled up to 7 gigs of information that we gave to our auditors. And the screenshot I'm about to show you, it is a real depiction of the auditor's face. All right, guys, that is all I have for you today. Thank you for coming to my session.